Welcome. I am Aaron Burnett, founder and CEO of Spaced Ventures, and we're going to be doing a Q&A with James and Finn, founders of WaveMotion. Guys, how you doing?
Hey, pretty good, Aaron. It's another beautiful day in the Pacific Northwest.
Awesome. So, we're going to go ahead. I know we had some technical difficulties before, and now we have two of you guys on one computer. This will work. I trust it. We will get through this. So I'm going to go ahead and just kind of shoot some questions that are coming from our community, right? We have all these folks. We have over 100, I forget how many, 130, 40, whatever, people that have indicated interest so far in your company, still early, and they have a bunch of questions for you. So this isn't all the questions that were asked, and we added a couple of our own in there as well because we're curious folks too. So we're going to kind of shoot through several questions and just see how this goes, all right? All right, so the first one is, I just kind of want to hear your guys' backstory. How'd you meet, who you are, like what's your backgrounds individually and collectively, and we can jump in from there.
Sure, I guess we can start with our individual backgrounds and kind of how we came together. So I have a bachelor's degree in physics from the Massachusetts Institute of Technology and made the jump from the East Coast to the West Coast when I came to the University of Washington to do my doctorate in the Aeronautics and Astronautics department, where I was going to be working on a plasma physics experiment for energy generation and space travel.
Oh, yeah. Well, I got a degree in mech eng at UBC Okanagan up in British Columbia. Then I moved down here to Washington State to get a degree in aerospace engineering at the UW, and that's where I met James.
Yeah, and kind of all fell into place. So one day during a professor-student kind of group lunch that the department was having, Finn tracked me down after the lunch because he had heard that I worked in a nuclear fusion group, and he wanted to ask me some questions about using impact fusion with metal-shelled plasmoids. And I knew immediately that this was going to be someone that I could have good conversations with. So as we kind of developed the friendship, he introduced me to this launcher concept that he had been working on. And I found it pretty fascinating, this idea that you can propel something using a propulsion source from the ground, just kind of reflecting off of it. And so I started joining him in his basement as he was tinkering around with these first prototypes. And we realized that if we wanted to pursue this project in any sort of real scale, we would need more resources, we would need more money. And so it kind of just made sense to take the venture at that point and formally form a company. And we started entering the business competitions and winning grants from the University of Washington, just pocket money to kind of support those first prototypes. But from there, we managed to build our proof of concept and get our Navy contract, and now that's all history.
Mm-hmm. And really, it was James that had the idea of doing a company. I mean, I was thinking that I would get a NASA fellowship or something and get a PhD, and thank God he convinced me otherwise, because right now I'd be a PhD student instead of a CEO.
Yeah, and even though I had plans to get my PhD, I always also planned to go into business for myself. I never really liked the idea of wanting to go to work, so I originally wanted to start a fusion startup, but I saw that there was more promise and potential in space as it's developing right now. It's a really exciting time, and being in the space economy at this moment could mean that you could play a pivotal role in the way that technology is going to be shaped for the next 100 years.
Well, I won't disagree with you there. I may be, one of the most optimistic folks about the future of space that you can find. So I 100% agree with you. So let's back up just a little bit, and we're talking about space. When we think of space, we tend to think of rockets because getting things into space is a pretty big deal, pretty difficult to do. But there's kind of some new concepts, which you guys are one of, this concept of kinetic launch. And can you just kind of briefly explain why are rockets being used now, and why are we thinking kinetic launch? Why aren't rockets good enough? Just to kind of give that broad background, just so that we can get a sense of why you're doing this and why it matters.
So I think it was a long shot space. The CEO over there that we're acquainted with did a good write-up on this. I think it was a month or two ago now, really what it boils down to is that rocket technology benefits from a huge amount of investment because it's derived from missile technology. And so it's starting at this relatively high level for technology readiness level ready for commercialization. But really, it's not the best potential way of getting things into space. There are thousands of other different ways you can think of to bring things from the ground into orbit. It's just that the technology hasn't had that investment yet. Now, specifically for kinetic or these impulsive launchers where you impart all the velocity from the ground, the general idea here is that you benefit from having all of your launch infrastructure, all of your complex machinery that imparts velocity to a given payload. You leave it all on the ground, so it's easily accessible. It doesn't need to be aerospace grade technology. That's your big one. Two, because it stays on the ground, you don't need to carry a great deal of propellant along with your payload. So you're imparting all your velocity at launch.
Rockets not only have to carry their payload, they must carry their fuel as payload. So as a rocket is reaching a certain speed, not only does it have to take all the fuel it needs to burn to get to that speed, it needs all the fuel it needs to carry the fuel to get to that speed. So we have this exponential problem of the faster you want to go, the more fuel you require, and what that ends up meaning in engineering terms is that you have these vehicles that are now 90 to 95% by their mass just propellants to get that 5% mass that will be the payload into space. And in order to have a robust space economy, in order to have any kind of space economy, you just can't have that sort of economics behind your vehicles. You need economics that are more similar to what we see in jetliners or ocean transports for cargo, where the fuel that they carry with them is comparable to the amounts of cargo they can carry.
Yeah, exactly. Like if you look at an oil tanker or a bulk carrier, those are relatively cheap vehicles for something that's 1,000 feet long and weighs 100,000 tons. But if they had to carry 30 times their own mass in propellant, they're never going to get cheaper. Certainly you can get to a pretty low point with reusability as SpaceX has done. But there's always going to be this floor value that's imposed by the engineering difficulties of operating a machine with that kind of propellant to structural mass ratio.
So this is a great kind of segue into, all right, let's try and get, sounds to me, right? I'm going to dumb this down for myself, right? Let's try and get more of our infrastructure and actual propellant on the ground so that we can just get as little as maybe only the payload up into space. We don't have to carry all that fuel with us. Okay, so that makes sense. So brief introduction to how the jet gun fits into this kind of narrative. I would love to hear, how does it work and how does it fit into that narrative from the creators of the jet gun?
Yeah, I can get this one.
Yeah, it's from the creator.
Yeah. So the jet gun, we want to differentiate from this new, space launch specific. Well, not really specific. We'll get into that later. But this other technology, the macron beamer, in both cases, what we're doing is we have a jet of some substance that we're projecting at high velocity from a machine on the ground. It's then hitting our payload and the vehicle that carries the payload. The momentum is transferred from this beam or jet of high velocity stuff. And off it goes, it flies away. The jet gun, in the case of the jet gun, that jet is composed of gas. So it's a very simple machine, right? You just have basically a rocket engine that operates at very high pressure. It shoots off a jet of gas, off away your payload goes. And we think the jet gun is suitable for launch up to about 2.5 kilometers per second, roughly. Beyond that point, we run into issues with acceleration in a nutshell. So the problem with gas jets is they mix with the gas in the atmosphere. Their momentum gradually dissipates. So there is a certain length which scales with the overall size of the jet gun device, over which you can push stuff. And if you exceed that length, you're not really pushing it anymore because your jet has just dissipated. Now, for several years at the start of the company, we were pursuing the jet gun for space launch, but looking at the developments like, reusable rockets becoming routine, the development of the Starship launch system, all this stuff made us think, it's not good enough anymore to have something that can launch cheaply if it's launching at these necessarily high G forces. It's just not marketable. So we threw our efforts into developing something that would be able to accelerate payloads over a much longer acceleration gradient, which would allow it to bring the accelerations down from this roughly 2,000 G level down to something that's comparable to a rocket, so in the 5 G range.
Interesting. So, sorry, James, just to kind of recap here, right? Then the concept is, right, jet gun. It's almost like an inverted rocket. The engine's on the ground, shooting something up, and we got something rolling up that way. And then the macron beam and that's going to be good. So, sorry, that jet gun's going to be good for suborbital sort of things, right? There's different use cases for that. Some in defense, maybe some others. Gotcha. Okay. That makes total sense. And then, your macron beam gets you, in theory, is going to be able to get you, into an actual launch kind of cadence. So this is great. We won't dive too deep into the technology, right? Because we got a whole list of questions we kind of want to, plow through here real quick. So moving on to the next thing here, what are the potential customer bases for whether that's a jet gun or, a macron beam that's launching things into space? What does that look like, that customer set?
Right. So there are two groups of people that need things going very fast from one location to another. One of those are orbital customers. They need something from the ground going into orbit at 8 kilometers a second. The other are typically militaries. So our beachhead market for the jet gun technology that's currently developed is going to be the U.S. military and allied militaries, maybe when it gets to it. So the jet gun, because it just has this nozzle at the end of the chamber that emanates the jet, rather than having a physical barrel or any sort of structure, can be vastly more compact, 5 to 10% the size of a gun that has the same amounts of power. So you can take things like artillery pieces and shrink them down to a form factor that's man portable. And that's very enticing, especially for the Army and the Navy, the Marines. So that's one of the driving forces behind the contract we currently have, which is that contract is investigating the jet gun technology. Now, but our ultimate goal really isn't to be a defense contracting company, it's to be a space launch company. So when we look at the customers in space launch, we're not looking at the traditional customer base that we see a lot of launch providers targeting today, and that would be small satellites. So rather than targeting small satellite launch, because we think that's not necessarily going to be sustainable or economical, we're focusing on customers that are looking at building infrastructure in space. So companies that need to get large amounts of mass that are necessarily constructed from the surface of the Earth into orbit, like those that are building space stations, so Axiom Space, for instance, and you also have perhaps even Blue Origin if they'd be open to working with other launch providers. You have companies that are manufacturing in space, such as Varda and Made in Space. And as they expand their operations out, they're not going to need little packages of 200 or 500 kilogram satellites. They're going to need multiple tons of equipment and materials and supplies to build out that infrastructure. So that's our main target in space launch, are those in-space operators who aren't just operating a single satellite in a single orbit, but are manufacturing and expanding into space as an industry.
Which, I love that, right? Because you think about the future of space and infrastructure that's required, a lot of historical parallels to what you were doing back in the day with moving from east to west. Got to move big bulk things to really start to, build that infrastructure in space. So that makes a lot of sense. So it sounds to me like it could be any commercial, not any, but probably a pretty large swaths of commercial opportunities, as well as government contracts and agencies down the line if they're starting to put some like interest in infrastructure building as well, right? So that sounds very logical to me. So now one of the questions is switching gears just a little bit here is talent, right? So I got a couple of things that kind of go hand in hand. Tracy and John asked similar questions about talent. One was, what do you think the types of jobs you're looking for, opening up as you grow? What do those jobs look like? Because what you're doing is a little bit different than rocket scientists, but maybe in some cases the same. And then how do you think you're going to be able to attract that talent over time?
Yeah, sure. So on the top talent side, this is actually something that we haven't thought about because there's just three of us at the moment, and our hiring opportunities for the next year or two are going to be limited to, I think, a few electrical or mechanical engineers and machinists. But on the talent side, the way we see it, if we can beam energy from the ground to a vehicle, we don't need our engineers to be geniuses who can shave grams off our vehicle mass or add another extra half second of ISP to our engines. We'll just throw mass at the problem until it goes away. As long as we can get that macron beamer going, and when it comes to macron beamers, for what it's worth, we are the top talent. Our hope is that when it comes to the actual vehicle design, the people that design it and manufacture it need not be any more skilled than the regular engineers that put together airplanes and cargo ships.
Interesting. So kind of the SpaceX kind of model of welding a giant steel starship together, right?
Except even easier because our structural mass fraction is going to be 5 times larger.
There's a question even of what is top talent, right? So as Finn alluded to, these aren't going to be traditional aerospace structures. I think as we go forward, as we've done already with interns that we brought onto the company, so we have only 3 full-time staff, but we do have an intern working for us. We really like to see what they can do in terms of skills and in terms of what their resume is. They don't need to have gone to the top programs. We're looking for, the best person we can find for the job in any case. And once they are in our ecosystem, we're happy to also train them. As Finn said, this is a very non-traditional system, so there's a lot for anyone to learn, even a, MIT-trained PhD rocket scientist.
Yes, even a physicist admits that he has something to learn here.
That's it's a physics joke there for you, but it's one of those ones where I think that, I think it's quite inspiring, right? When you're thinking about, and we have these conversations all the time, space feels quite inaccessible, right? And you guys are talking about a future where skilled labor is in a critical part of this, and it's not only PhDs or whatever doing things. It's a large group of the population that have opportunities to actually turn the wrench, build the thing that pushes humanity into space. And I think that is the future here as we start to evolve the industry. So it's very cool to see that you'll probably have a fairly significant, in theory, if there's success, you'd have a significant workforce where the accessibility is quite high. So, kind of a little bit of a gear switch here, back into the actual technology. And you've referenced the difference between a jet gun and a macron beam, right? I think that's fairly clear at this point. When do you think you're going to be able to test John is asking, when do you think you'll be able to test the macron beamer's ability to launch payload into space?
Sure. And I think we forgot to mention this earlier, but the differentiator of a macron beam is that instead of using a gas jet like in a jet gun, it uses a jet of solid particles, like small grains, a few tens of microns across. So the property that we're taking advantage of here with these solid particle jets or macron beams is that they self-focus in the atmosphere rather than dissipating apart like a gas jet. And because they self-focus, they remain, tight and lose little energy to drag. We can accelerate payloads over a much, much further distance and have that nice low acceleration that we want, depending, of course, on the power put out by the macron beam. So the next year or two, what we'll be working on is a series of iterated prototypes with a macron beam that puts out roughly between 1 and up to 100 kilowatts. And these will be suitable for the manufacturing application of macron beam technology. Now, for an actual orbital launch facility, likely we'd be looking at a macron beam in the gigawatt range, which is a lot more. As a sort of transition step between those 2 points, what we want to do is put together a macron beam that's roughly in the megawatt range. It won't be suitable for an economical profit-generating orbital launch facility. It will only be able to accelerate roughly a few kilograms, if we're lucky, to orbital velocity. But we'll be using it to test out the control systems that we'll need on the vehicle, the shielding gas that we'll need on the base of the vehicle. We'll be using it to familiarize the FAA with the technology, and of course attract investment, because now we have something we can point to and say, hey, we just need to scale this up by 3 orders of magnitude, and then you'll have a sustainable business. So that would be no earlier than 2024.
Gotcha. So we're thinking, what would you say, 100 kilowatts was the first, just an early proof of concepts, or something in that range. Megawatt is probably a 2024 kind of concept, but that would be, in theory, get you all the way to a proof of concept of an orbital or some kind of actual space launch, correct? Just so
yeah. And the nice thing here is that, unlike a rocket engine, there's all sorts of weird things that can happen when you scale up rocket engines. But with a macron beamer, it's essentially just a particle beam. So you think about it this way: if you have an electron beam like in a cathode ray tube, like an old TV, it's going to work pretty much the same way whether you have 2 TVs next to each other or 2,000 TVs sitting right next to each other in a big pile. There's not going to be any weird stuff going on because you've got much more power in a small area.
Gotcha. It makes total sense. And so obviously this is early stuff, but we're investing in infrastructure here at the earliest stages. So totally understand that. Totally understand there's some time involved. And this is the nature of the space industry, right? Build, actual physical products, test. It takes time. And so keeping that in mind is a good thing for investors to know. Greg, I'm going to move on to the next question. Greg was wondering about the minimum raise required. So the amount of money, like what's that smallest amount of money that allow you to get through your OTA milestones and then into your proof of concept, and what kind of additional raises do you think will be needed? So you've already touched a bit. There's going to be additional raises, right? This isn't like a one shot and done, right? You're making money tomorrow kind of thing. This is going to need some stuff. So what does that look like? What does this current raise look like, where if you can raise a certain amount, you can actually have some meaningful impact and grow the company?
Sure. So for the OTA contract we have with the Navy, we don't really need any additional support. When we write these contracts, when you budget out a military contract, the idea is that you have the full budget for everything that you need. Everything is already accounted for and paid for. So things like Finn and I's salaries, the equipment that we would need, money to pay machinists. Now, that doesn't mean that your estimates are always perfect or that it's always easy. So having a little bit of cash in the bank, while it's not necessarily, would certainly help us loosen our belts as we execute this OTA. And most importantly, give us additional money to work on the macron emitter, which is the main thing. So the jet gun is a fairly simple device. It's basically just a rocket motor, and you can build it in a garage with fairly simple tools. Because the macron emitter has a lot more working parts, and now you're dealing with something that is electrically powered rather than chemically powered, there's more complication to it. So the development costs for the jet gun were about 20 grand. So it's more complicated, I'd say, by an order of magnitude. So scale up that 20 grand initial development cost by that same order of magnitude. To build out a proper working version of the macron beamer that would be suitable for a market such as manufacturing, which is another market that we were looking at, I forgot to mention earlier, but the macron emitter, even if it doesn't scale well for space launch, which there should be no reason that it doesn't, we can still immediately start generating a profit using macron beams as cutting tools. So if you fire a stream of little particles, think of it like a sandblaster or a water jet, a stream of particles moving at several kilometers a second can easily cut through things. And if you slow that down, you can additively manufacture. You could weld and cold spray on materials. So to get to that point would only require, by our estimates, around $200,000, $250,000, which is why we're going with such a small kind of first raise. The seed phase will allow us to build that proof of concept that both allows us entry into other markets and paves the way for showing that the macron beamer works as expected, scales as expected, and then when we build a bigger proof of concept, as Finn mentioned, that it will work and launch things at orbital velocity.
So this is, just to provide context for everyone, this is one of the things that's amazing about space, and I always like to remind people of this. Space is a place, not an industry. Right now, it looks like an industry. It's its own specific things, but you're just building stuff that accesses space in your case or interacts with space in some way. It forces humans to create innovations that invariably have impacts across the economy. So what you guys are doing, right, this macron beamer, turning something that could, what we really want, the pinnacle of this is an awesome, super efficient, very cheap cost per kilogram to orbit launch vehicle, launching vehicle kind of thing, infrastructure, I should say. But if you fall short, you're aiming for the moon, you reach the stars, right? I guess in this scenario, there's really a good chance you end up with a pretty significant, manufacturing tool at the very least. And that's what you're hoping to see happen right over time. Okay, that makes total sense. And then when you line that up with potential raises, what you think you may want to try and go out here, just to remind everyone, WaveMotion is in a kind of a test the waters kind of phase right now, seeing what kind of interest there is in this concept and this business plan. So there isn't an exact number that's been totally nailed down yet, but the thought process is you don't really need all that much to at least get to that next step, right? And this is the way businesses are built, step by step, really try and get the minimum amount to go to the next step and the minimum amount to go to that next step. But with that, I will ask, what do you think? And this is a total estimate. We won't hold you to this, but what do you think is that, that megawatt and then even that gigawatt scale of, a macron beam? What do you think that costs?
So Finn actually did a calculation on what a space launcher facility would be. And the answer is actually pretty surprising. So Finn, what did your calculation?
I'm estimating roughly $60 million to get a 30 tons to orbit facility up and running. And of course, with inflation, that can go up.
Yeah, that's $1 million
in
2022
August 2022 money.
Yeah, the month matters. That's right.
Inflation just recently went back down. Everyone was happy about that. So hopefully it's not. Hopefully it's not crazy. We'll see how that goes. But okay, so just to give everyone that context, 60 million sounds like a lot, especially when you're talking about crowdfunding scales, which generally, top out at 5 million. But this is how a lot of the industry goes, right? You raise a chunk, you get to that next step, and then you raise that other chunk. Now, to put that into context, right, when you're talking about infrastructure investment, all that stuff, what was the estimate SpaceX invested for 4 rockets that he tested before he actually got to orbit? What was that number? It was in the hundreds, 120, 200 million?
Total development costs for Falcon 9 were in that $100 to $200 million range to get it up and running, I want to say.
And that was the Falcon 1, wasn't it? Right? So it wasn't even Yeah, so
we'll have to look into that. I can't remember it off the top of my head, but it was.
Yeah, don't quote us, anybody.
For context, though, $60 million is about the price tag of a fully expendable Falcon 9 if you were to go out and get one. It's about $65 million. For that same price, we are not building a rocket that can at most be reused 10 times, a dozen times. We are building an orbital launch facility that can be reused hundreds of times, possibly, before any sort of maintenance or downtime is required.
Yeah, so this is the power, again, when we come back kind of full circle to the Kinetic launch facility. This is what companies like Spin Launch and Green Launch and Longshot and others, WaveMotion isn't the first person to ever think about this, like some kind of infrastructure, right? This has been thought about I think way back with the Germans back in World War II, they were thinking about this kind of thing in more of a defense angle. But, this has been thought about. This has just not been, economically tested. There are other people doing it in different ways. So, it's not crazy to think, but this is where potentially, if these things start to take off, you're talking about infrastructure, highly, highly reusable infrastructure that allows you to really reduce your cost, because it's something that you can turn the wrench on the ground. You don't have to have something that's going to fly into orbit. All the infrastructure is flying into orbit. It's on the ground, it'll rust, whatever, but you can replace it quite easily.
Yeah, and importantly, you can use a lot of off-the-shelf hardware. For instance, we need a power source for this macron beamer. It's in the gigawatt range. Our working plan right now is just a simple steam turbine that's been optimized not for reliability and time between maintenance intervals, but rather for power density and low capital cost. Or an array of steam turbine generators. And all of this is powered off big hot water tanks, off-the-shelf tanks, the hot water heated with natural gas using off-the-shelf heaters. I think you can get, they're used for fracking, but there's these trailers you can get secondhand for, I want to say 50 to 100 grand. And they put out 10 megawatts of heat. So, just get a couple of those, and your orbital launch facility has all the energy that's required as long as you've got a natural gas coming in.
Yeah, luckily components do not need to be aerospace grade when they are not going to the air nor space.
Exactly. Exactly.
Yeah, this is just, really interesting conversation, but I will go on to the next question, which does relate here because you mentioned this before. But John, I think we have a lot of Johns, or someone with one or two Johns with a lot of good questions. He was asking, given the rate of acceleration of your current jet gun, and you already touched on this, but let's put a fine point on it, and the macron beam, what is your strategy for eventually launching humans or other G-sensitive payloads? So kind of explain that. I think we did touch on this a little bit, but you kind of was brushed over. Let's go a little bit finer point on that.
So Finn mentioned before the relationship between the distance and the force that you need to accelerate something up to speed. So think about this versus getting up to speed on the highway. You have this long on-ramp, right? And so you gradually go up to speed. You don't really feel that much force in your car. Compare that to a drag race, where within the space of, a few meters or a few tens of meters, you're instantly being thrown to 150 miles an hour. You're going to be shoved back in your seat because you're experiencing more force over a shorter distance, even though really you're going to about the same speeds, at 150 miles an hour versus 60 miles an hour on the highway. But it's comparable when you're talking, relative to orbital launch. So the longer you can make that path, the less acceleration you feel. So with the jet gun, because that jet dissipates after a short distance, after tens of meters in our current prototype, or not even that, meters in our current prototype, you have to make the force to get up to a certain speed extremely high. So that is the case where we have tens of thousands of Gs or 10,000 Gs on launch, and that's not tenable for humans. So the macron emitter, because it can punch through the atmosphere, now instead of having just this path that's tens of meters or hundreds of meters, you have a path that is tens of kilometers. So you don't have that drag strip where you're being thrown back. You now have that highway on-ramp where you have lots of time to gently accelerate up to the speed that you need. So that is how we plan to launch humans, is that we don't until we get the macron emitter fully working and demonstrate that low acceleration. And once it is working properly, any payload that can withstand 2 to 3 Gs of acceleration, much less, will be able to go on. And that includes humans.
That is very cool. And I know I could probably talk about that all day, but sounds to me like there really is a path that could mean we are looking at humans riding on a macron beam someday, in addition to large payloads that don't really care about high Gs or something like that. So, obviously, I don't think you're trying to sit here promising, that this is a guarantee or anything like that. But, this is something where it seems like it's an engineering challenge, which is a big one, but it's not a, we need to invent new laws of physics kind of thing. So that's where it gets really exciting because we're kind of there. Now, I'm going to transition to a very different topic. And we have several questions that come in along this. And I'll preface this with, these are business, exit related, return related questions. So there's really no guarantee that can be given. No matter how confident Finn and James are, no one knows, right? And investing at early stages, especially in aerospace or any kind of deep tech company, there's long timelines, a lot of risk. So make sure that everyone's aware of that. So we had Samuel, we had Ferrara, and we had Michael all ask relatively similar questions. So I'll kind of frame it for them. Are you considering potentially an IPO or some kind of exit? And what do you think that, what that sale could look like as far as over the next few years, or, what's that timeline look like? And what are you targeting as a potential exit kind of opportunity? I mean, just, again, no guarantees, just what are your thoughts and feelings on exits and what that looks like?
Yeah, so we see it on IPO as one potential exit, but definitely not before I would say at least 7 years from now. I mean, I would not see us doing an IPO before we get something into space. Other companies have done that and it hasn't worked out. Yeah. Not naming names. Yeah. And then as for current early stage investors, we will be seeking investment likely over the next 2 to 5 years as we attempt to build this orbital launch infrastructure. And as those investment rounds come in, those will each be an exit opportunity for our current early stage investors.
And while this is not necessarily an exit, part of the business strategy overall is to transition away from the defense side, which is very regulatory, even more so than space. So as we develop the jet gun line of the technology, our plan is to license that to a large prime contractor like Lockheed Martin or BAE Systems, for instance, possibly in a deal through their venture arm, because a lot of these prime contractors also have venture arms these days, so that way we can also raise around. But we would be looking at licensing that technology out so that way it's no longer actively being a drain on resources where we have to develop it, but instead it's just now pure revenue generation. BAE Systems writes us a check every time they sell a jet gun system fully integrated to the U.S. government, sort of thing.
That would be ideal.
Yeah.
And another option there would just be us as subcontractors building some component of the jet gun that we're experts on, which right now is just about all of it, and then selling that to BAE.
So
another defense contractor.
That's the benefit here, then, right? Of having, again, space technology often has multiple potential use cases, dual use, or maybe even triple kind of use cases here. You guys are talking about not only a defense angle, but also potentially an angle for manufacturing. But you guys are really focused on the future of orbital launch and getting humans as well as mass cargo into space. So your hope is, assuming everything goes to plan, there are ways to create additional revenue sources that kind of offload your, attention sucks, and you can put all your attention into what's really, the thing that wakes you up in the morning, right? So very cool to hear, with that. That is all of our questions, but I want to give you guys a couple of minutes here if you need it to any final words, any parting words, things you'd like to say to people who are considering putting an indication of interest into the platform.
Just a quick note here, I guess. One of the benefits I think of this delay in the fundraising just due to the escrow provider is that we will have a macron beamer prototype up and running that we can show off to people. Fingers crossed if nothing goes wrong, and it probably will. Within the next few weeks or so. So we're excited to show that off. We should be able to slice through some stuff for potential investors, and they can see us, just zipping
very cool
that macron beamer.
Yeah, and we're still pursuing opportunities. This Navy contract is a feather in our cap. but there's definitely a lot going on behind the scenes. We're looking for new contracts. We're talking with a lot of big players. We're starting to line up partnerships and relationships with people in the defense and space side. So expect some big things from WaveMotion over the next few months, both technically related and business related.
That's exciting. It's really cool to see. I know I personally am a big fan of these kind of infrastructural kind of investments because, if we want to go to space, if we want to have mass amounts of people, humans, industry in space, then we're going to be needing these kind of things. And I'm excited to see what you guys are doing, excited to continue to see this journey. And, if there's any other investors or people that are willing to do or interested in doing an indication of interest, now's the time. And thank you for the time, Finn and James.
Yeah, no problem.
No problem. Great as always. Thanks.